Hi everyone, Dr. Saiti here, Team MDS Conquer. So next I am going to give you a brief idea of important aspects related to basics in oral radiology. Okay, so let's start. So paralleling technique is one of the most important intraoral radiographic technique, and that is being developed by the Gordon M. Fitzgerald. Okay, here the object, that is the tooth, the receptor, which is a film packet, as well as a position indicating device, all are kept in a parallel plane, right? And it is also called as a right angle technique. Why? Why? Because the central ray is perpendicular both to the long axis of the tooth as well as to the film. That's the reason it is also called as a right angle technique. Next, it is also called as long cone technique. Why? Because a 16-inch long cone is being used, so it is also called as a long cone technique, right? So these are the important points related to paralleling technique. So the main principle is the central ray should be perpendicular both to the long axis of the tooth as well as to the film, and to obtain this parallelism, the film and the object, the distance between that is being increased. Okay, so the film is placed away from the tooth towards the middle of the oral cavity, so that there is increased distance between the object and the film, and both the film and the tooth will be parallel to each other, so that the central ray will be perpendicular both to the film as well as to the long axis of the object or the tooth, right? So that the exact principle is being obtained or is being achieved. So now the distance between the film and the tooth is being decreased, right? So it's being increased. Actually, if you follow the rules of projection geometry, there are few important rules that is being given in projection geometry. Number one rule is there should be less distance, or the object and the film should be as close as possible, right? So less distance should be there between the object and the film. Next is there should be more distance or increased distance between the target and the film, right? And the other rule is the central ray should be perpendicular both to the film as well as to the long axis of the object or long axis of the tooth. So these are the main rules that are being given by the projection geometry, right? Here in the paralleling technique, only one rule is being gone, or it's not being followed, that is the distance between the film and the tooth. Actually, the distance between the film and the tooth should be as close as possible, but in order to achieve parallelism, we have increased the distance between the film and the tooth. Except this rule, all the other rules are being followed by the paralleling technique. That's the reason the image produced by the paralleling technique is even more better when compared to the bisecting angle technique, right? So now the distance between the film and the tooth is being increased to achieve the parallelism. So that can cause magnification and also loss of definition. So in order to compensate that, the target film distance is being increased. So 16-inch cone is being used. So that's the reason it is called as a long cone technique. So this again results in less magnification and increased definition. So because of which a good image is being produced. So this is the main reason why for which the paralleling technique is preferred to get a good image when compared to bisecting angle technique. So coming to the next technique, that is the bisecting angle technique. So it is actually introduced by Wetson A. Price and is also called as a short cone technique. Okay, here a short cone is being used. So the basic principle is it follows a Szymanski rule of isometry, right? So here you can see these two triangles, if they share a one complete side, then they have equal angles. So that is the Szymanski's rule of isometry. So here the central ray is neither parallel, it's neither perpendicular to the long axis nor it is perpendicular to the film. It is actually perpendicular to the imaginary axis which is drawn in between the triangles that is being formed as a consequence of the long axis of the tooth and the film. Okay, it is not perpendicular to the long axis, neither it is perpendicular to the film, it is actually perpendicular to the imaginary axis. So as you can see, the central ray is actually perpendicular to the imaginary axis. So That is the main concept and the principle related to the bisecting angle technique. So, these are the various angulations which you need to have an idea. So, while practice you do remember all this. So, just have a look of the various angles for different projections or for different teeth, like for incisors for canines, premolars and molars. So, just have an idea of the different angles that have been posted here. So, these are the various holding devices, right. So, there is a styrofoam film holder which has a 105 degrees angle and a easy grip folder or a hemostat. All these are the various holding devices for the bisecting angle technique. Next is a bite wing radiography that is being introduced by Raper and is also called as interproximal radiograph. So, actually it is mainly indicated for interproximal caries. Okay, so that's the reason it is called as a interproximal radiographs, and also to know the periodontal status, right. So, even in early stages of development, before it is clinically apparent, bite wing radiographs can clearly give the image or clearly give the interproximal caries. Okay, so that's the reason it is also called as interproximal radiographs. So, next, apart from the regular films that we use in digital imaging, we use the CCDs and CMOs, okay, in order to get the image, right. So, digitally these two are being used. So, what is the basic difference between the charge coupled device and the complementary metal oxide semiconductor? So, CCDs and CMOs. So, first one is a CCD. So, both these are actually made up of silicon, okay, but the basic difference is a bucket brigade fashion. So, bucket brigade fashion is being exhibited by the CCDs and it is not seen with CMOs. So, coming to CCDs, so CCDs charge coupled device. So, it consists of a thin wafer silicon, right. So, whenever this thin wafer of silicon is being exposed to radiation, the covalent bonds is being broken. So, there are covalent bond which is present between the electrons that is being broken, and this electron will form pairs. So, this electron pair will ultimately get attracted to the positive potential and results in formation of charge packets. So, each charge packet corresponds to one pixel. Okay. So, simple concept, it is made up of silicon. So, when that silicon is exposed to radiation, there is breakage of covalent bonds. So, as a consequence of that, electron pairs are formed that gets attracted to positive potential which form charge packets. This charge packets corresponds to 1 pixel. Okay. So, the signal is transmitted from one signal to one pixel to other. So, there is a signal, right. So, that is transformed to one pixel to other in form of bucket brigade fashion in CCDs, okay, whereas that is not seen in CMOs. So, finally, that signal is being amplified and it is transmitted to the transistor, and with analog to digital converter it is being displayed in the computer. So, this is related to CCDs. So, from one pixel to another it is being jumped, the signal is being transmitted by bucket brigade fashion in CCDs, right. In CMOs, each pixel is isolated from another. It is completely isolated from another, and each pixel is individually connected to the transistor. So, there is no such bucket brigade fashion in CMOs. So, that is the major difference between the CCDs and the CMOs. So, next, coming to the other important basics related to radiology is the grids. Okay. So, grids are the devices which reduce the amount of scattered radiation that is reaching the image receptor. Okay. So, it improves the diagnostic quality of the radiation, okay, right, but it can increase the exposure to the subjects, but main thing is it reduces the scattered radiation and improves the image quality, right. So, that is the important concept related to grids. So, grids is again made up of lead. So, though it increases the exposure to the patient, but it gets a good image it improves the quality of the image and improves the diagnostic quality of the radiograph, okay, because it reduces the amount of scattered radiation which is reaching the image receptor, okay. So, that is related to grids. So, what is the important concept behind grids is the grids made up of lead, okay. So, that reduces the scattered radiation towards the image receptor, so that it can improve the diagnostic quality of the radiograph, right. So, as you can see here, it is made up of lead, the film shows there. So, alternate bands of lead. So, next are the intensifying screens. So, intensifying screens are those which emit the visible light. So, they contain phosphors which emit the visible light when struck with the X-ray photons. So, whenever they get the X-ray photons, they emit the visible light, okay. So, depending upon the phosphor used, the screen will emit the light either in a green or a blue spectrum. So, these are the rare earth materials. So, green is being by the gadolinium oxysulfide, and whereas blue is with yttrium tantalate, okay. So, the types of intensifying screens, the slow screens are made up of calcium tungstate, and the rare earth are the faster screens which is made up of gadolinium or lanthanum, okay. So, just have an idea of that I have posted here. So, the main important thing is the composition of the intensifying screens. So, intensifying screens, as I said, they consist of phosphors which emit the visible light whenever they get struck with the X-ray photon. So, all this is related to the extraoral radiography actually. So, intensifying screens are being used with the image receptors when extraoral radiographs are being taken, okay. So, the base, you can see the yellow line is made up of plastic and it actually provides a good support. The reflecting layer, the next one, it reflects the light which is emitted by the phosphor back towards the film, okay. So, this one is side towards the film. So, this reflecting layer, it is reflection. So, it reflects the light which is emitted back towards the film, okay. So, the phosphor layer, the green line, consists of phosphor crystals which emit the light whenever it is struck by the photons. And the last one is the protecting coat, that which is a black line, which is again a thin layer of plastic which protects the phosphor layer from being damaged whenever the screens are handled. So, just remember the sequence of the layers, the base followed by the reflecting layer which is a red line that reflects the light which is emitted back towards the film, okay. Next, the phosphor layer which actually emits the visible light. The last one is the protecting coat. So, this is the exact composition and the sequence of composition. So, just you need to have a good idea, right. So, just another important aspects or important basic related things which you need to have a good idea I have posted in this discussion. So, just have an idea of what all I have discussed so far and make a good note of it, okay. Thank you.